and our earth is rotating. Okay. So, when you are above, when you see when the satellite, so is my confusion, I do not want to do this, let me draw it the other one itself, that is better. Or the easier way to show you is, imagine earth is rotating like this. Okay, earth is rotating like this, and this line which I am drawn, this is the equator. If you are standing on equator, you will find the satellite always vertically above, and the way your earth is rotating, your satellite should revolve. The rotation time of the satellite, sorry, rotation time of the earth is equal to the revolution time of the satellite. That is what you should know. That is called geostationary. But there is something called GSO, geosynchronous. In synchronous, the only difference is, we expect normally to the satellite to be vertically above the equator and parallel to the equator, it is revolving. But in a geosynchronous orbit, same height, but it is at an angle to equator. So, it will be revolving at an angle to the equator. In a geosynchronous orbit, the satellite revolves around the earth at 36,000, approximately 36,000 kilometers. It will be traveling from west to east, वो भी ठीक है, but not vertically above equator, at an angle, a small angle to equator, at an angle to equator, maybe 5 degree, 6 degree, 7 degree, 8 degree, at an angle to equator. It is also synchronous, but slight variation. So, it will not be, when you travel, when the earth rotates from west to east, satellite also will be by and large in that direction, but it will be changing, satellite's position will be changing, but at a particular time every day it will cross the equator at a specific time. In a geosynchronous satellite, it will cross the equator at a specific time every day, because it is also taking 24 hours to complete one round, but it will cross the equator at a specific time every day. Suppose it is crossing the equator 6 a.m., next day again it will cross at 6 a.m., because it is also taking 24 hours to complete one round. Geosynchronous orbit, it is synchronous with the earth's rotation, but at an angle to equator. So, it will be crossing equator every day at a particular time. So, it is called geosynchronous orbit. So, GSO is almost similar to, or we can say GEO, geostationary earth orbit, is a particular type of GSO. I am repeating, GEO is a particular type of geosynchronous orbit. Earth would be far away from the sun as this satellite is far from, no, it is not far away and all, yeah, it is just 36,000. Our sun, earth to sun, the distance is 150 million kilometers. Geostationary satellite, 36,000 kilometers. So, there is no comparison whatsoever with sun. 150 million kilometers earth to sun distance, we are just 36,000 kilometers away, not at all far. Okay. So, it is a particular type of GSO. GEO is a particular, because if it is vertically above equator, if the inclination to equator is 0, then it is GEO. So, for a satellite, if the inclination with respect to equator is 0, then it is GEO. So, a GEO is also, geostationary earth orbit is also a geosynchronous orbit, but inclination is 0, that is the meaning. So, this GEO where do we use? See, this is very important for communication. Geostationary earth orbit is very important for communication, constant communication. It is very important for constant communication. It is very important for 24 hours TV channels, because the whenever our from earth, if it is relayed something, it should be received by the satellite and send it back. Earth is rotating, when earth rotates, satellite should always be above you. 24 hours communication. Or 24 hours weather forecasting. Cloud cover, etc. Any cyclone development, 24 hours if you want to watch a particular area, geostationary satellites only can help. So, communication, TV channels, radio communication, 24 hours weather forecasting, it can be done only by this kind of geostationary satellites, because we need constant communication, continuous. It should be always vertically above you. So, when the earth rotates, the satellite also will be revolving at the same height. So, one more thing, let me just remind you. I said earth, equator, and above equator we are talking about a satellite revolving at a height from equator, vertically above equator it is revolving. So, all communication satellites are located above GEO, this is GEO. So, whether you are a country above equator or whether you are above far away, ultimately the communication has to be there. Or let me just put it this way, say above equator, satellites are located above equator. Suppose you are standing at equator, where do you find? Vertically above, 90 degrees above. I will show you like this. This is equator, satellite is located here. So, vertically above equator. Suppose you are standing at 10 degree north. So, it will be at an angle to you, because satellite will be located at an angle, but above equator. Or, so this is equator, you are standing at 10 degree, it is like this on both sides. Suppose you are at 20 degree, again you can see, sorry. So, if you are to have a dish antenna to receive the signal from the satellite, if you are standing at equator, your dish will be vertically looking up, but if you are at 10 degree, the dish is like this. If you are at 20 degree, the dish is like this. Just see, say in North India for example, your dish antenna's location, where is it the dish looking? The dish is always looking towards equator, wherever with equator, the dish location will be like that. So, if it is far away, you will see at equator it is vertically looking up, but if it is at equator, sorry, at poles, from poles how will be there? The dish may be at a slight angle, because it has to see, because even for a country near the polar region, communication satellites are located above equator. Then only this satellite can revolve in 24 hours to complete one round. Okay. So, that is what you please understand. This is the communication satellites we are talking. Communication satellites are located above equator. It is revolving from west to east. It is located at a height of around 35,784 kilometers, and weather forecasting, constant communication, everything is possible from there. Then there is another name called GTO, geostationary transfer orbit. There is another orbit called geostationary sorry, polar earth orbit. We will talk about that polar earth orbit, please wait. Geostationary okay, geostationary transfer orbit. That means when you launch, now imagine from earth. So, if this is the height required to be revolving around the earth, ये ऑफ होते जा रहा है, ये काम नहीं करेगा तुम्हारा कंप्यूटर. So, from earth if this is 36,000 kilometers above. Now, what happens is when you launch a satellite, suppose a communication satellite is launched, it is not, while launching using a rocket, it is not launched directly to a circular orbit like this. Initially, it may be launched in an elliptical orbit like this. It may be something like this. Initially, when it is launched, it may be launched say into a highly elliptical orbit. Then it will revolve around the earth for some days there. Then slowly this, using commands and operation from the master control facility or the ISTRAC, the ISRO satellite tracking center. Okay. From here or from the master control facility, slowly this satellite's orbit will be raised, such a way that it will ultimately become a circular orbit. So, the first elliptical orbit, that highly elliptical orbit into which we have launched the satellite into, surrounding the earth, the first highly elliptical orbit into which we have launched a satellite, and subsequently that height of the orbit is changed by using that orbit maneuvering operations to make into a circular orbit. That is what is normally done for all communication satellites, because we are not directly launching into a circular orbit in the beginning. I am repeating, when a communication satellite which is to be launched at a height of around 36,000 kilometers, in the beginning, when the first day of launch, it is launched into a highly elliptical orbit with a ellipse of, as a nearest point, the perigee, Perigee means which is close to the surface, perigee of around 280 kilometers, and an apogee. Apogee means the farthest point, perigee is the closest point with an apogee of 35,000 plus kilometers. This kind of a highly elliptical orbit where the satellite is dropped in the first place, then slowly the satellite height is increased into a circular orbit. This is called GTO, geostationary transfer orbit. Okay. So, then Anurag Kumar मुझे लग रहा है Anurag is an engineer. Please remember, any object can revolve round if there is centripetal force. Only engineers have these kind of doubts. And the centripetal force is to the center of the earth. Okay. So, now when a satellite is revolving above equator, the centripetal force is to the center of the earth. So, if you are launching a satellite at an angle to equator like this, even at that time also the satellite's centripetal force is to the center of the earth. You cannot send a satellite above poles like this, it cannot. Why? Because centripetal force will be provided to the center of the earth. So, the satellite will have to revolve like this, if at all you want to do something like that. So, that is why in a geostationary concept it has to be vertically above equator, there is no choice. There cannot be above Tropic of Cancer and above pole. फिर तो आपके आइडिया में अनुराग कुमार जो इंजीनियर निकला हमारे क्लास में, पोल के ऊपर क्या ऐसे घूमेगा? हाँ तुम्हारा माता जो घूम रहा है ऐसे ही घूमेगा? Is it possible? No. Please understand, a satellite has to have its center, the center of gravity to be the center of the earth, then only it can revolve around earth. When earth revolves around sun and from the center of the sun, that orbit is where earth is revolving. Similarly, satellite will be revolving with respect to the center of the earth. If moon is revolving around the earth, that orbit is also from the center of the earth a circular motion. Okay, a slightly elliptical orbit, that is fine, but the centripetal force is to the center of that object around which is revolving. Okay. So, I hope you understood, Anurag. So, where to use of GSO, we will be talking about that GSO is used in certain circumstances, especially in navigation satellite these days. GSO is used in navigation, some of the navigation satellites, we will be telling about that. Okay. So, that is the situation as far as the various orbits are concerned. So, again I am repeating, I talked about LEO, MEO, GEO, GSO and GTO. Geostationary transfer orbit. Okay. Geostationary transfer orbit. Now, let me talk about our history of launches by India, because some of them are important. So, small history like when did we start launching satellites and things like that. So, that is where I would like to talk about the history. So, the first satellite to be launched by India was Aryabhat. Aryabhat. It was launched in 1975. At that time, we did not have any facility, we were the beginners. We took the Soviet Union's help, and a launch vehicle, this is a satellite, Aryabhat is a satellite, and we used a USSR rocket called InterCosmos. And the purpose of this satellite, why did we launch this? To create, in an experimental one, to create infrastructure for satellite launch. The launching should be there, the tracking should be there, to create to create infrastructure for satellite program in future. That is the aim of IRIBUT. No other specific purpose. We should receive some signal, we should know how to track it, so that our satellite revolves around the earth. So, first launch was IRIBUT, the name was IRIBUT. It is we took the help of the Soviet rocket InterCosmos to create infrastructure for satellite program in future. IRIBUT was launched. The second launch we did was called Bhaskara 1 in 1979. Again, it was by InterCosmos, again from USSR. InterCosmos. So, what are ALS, VSAT satellite? We will come to that. Okay, we are also using satellite technology to reach to people in different centers across India. I will come to that, please wait. Okay. InterCosmos, again it was the launch vehicle was InterCosmos, and this Bhaskara was a prototype remote sensing satellite. Okay, as an experimental Earth observation satellite. Is an experimental Earth observation satellite, that is Bhaskara 1, 1979. Then we also launched a Rohini satellite in 1979 again, but this was an experimental payload for our SLV-3. We were parallelly developing a launch vehicle also. SLV-3 is a satellite launch vehicle. And a satellite launch vehicle is used for launching the satellites. The name of the satellite is Rohini, that is in 1979. Payload, experimental satellite, is an experimental satellite to be delivered by our launch vehicle, satellite launch vehicle, that is how Rohini was launched in 1979. Then we launched another one called Apple. It was a satellite for communication purpose. It was launched by European Space Agency in 1981. But Apple's full form is Ariane. Passenger payload experiment. So, Rohini was happy that her name was called, but that is the name of our satellite. Okay. So, you can be proud that in your name we have a series of satellites, okay, Rohini. So, maybe Government of India thought about you, and that is how it was launched much before your birth itself. Okay. So, this is a satellite, the name of the experimental payloads. Even today, the Rohini series satellites are there, that is for upper atmospheric studies, but the first such satellite was launched was in 1979. Okay. Apple Ariane Passenger Payload Experiment, APPLE. Ariane is the European Space Agency rocket. It is the rocket of European Space Agency. In that European Space Agency rocket, we kept a passenger, a small payload for communication experiment in India. This is the beginning. This was the prototype of our INSAT and GSAT satellites. Apple is the prototype of INSAT, Indian National Satellite. It was there earlier, or GSAT satellites of India. So, basically it is for communication purpose. Apple was launched for as a prototype communication satellite. The first communication satellite to be launched by India was Apple, and finally, with this experiment we have launched our INSAT 1A in 1982. It was in 1981. Apple was in 1981. Then came INSAT 1A, 1982. Okay. What is the full form of INSAT? Indian National Satellite. Indian National Satellite. We have a series of Indian National Satellites, INSAT 1A, 1B, 1C, 1D, then 2 series, 3 series, 4 series. We have launched it, then subsequently we renamed it as GSATs. Okay. These are all communication satellites which we launched. INSAT satellites are communication satellites. So, in 1982 we started the communication satellite program. Then we also started our IRS program, Indian Remote Sensing Satellites, Indian Remote Sensing Satellites, IRS. And that is a remote sensing, means earth observation satellite is also, it is nothing but earth observation satellites. These are for photography, and our first IRS 1A was launched in IRS 1A was launched in 1988. By Vostok. Vostok is the rocket of Soviet Union again. Vostok of Soviet Union. So, these were the initial satellites launched by India. So, please remember, very important, first is Aryabhat, second is Bhaskara. Aryabhat was just to start our program. Bhaskara is the prototype of our remote sensing or earth observation satellite. Then Rohini, this is a payload for satellite launch vehicle for the rockets, the traveler, the passenger to be there in a rocket which you are developing. Then Apple Ariane passenger payload experiment. This is the beginning, this is the prototype of our INSAT the communication satellites. Then we started our INSAT program, INSAT 1A in 1982, then IRS 1A in 1988. Then hundreds of satellites we have launched. So, series of programs we had. So, that is how this IRS program and the INSAT program, right. Now, let us move into the draft space based communication policy. Now, recently the government has come out with the space communication policy. Space communication policy, or it is called Spacecom policy 2020. And it is under Department of Space or DOS, and as I told you, space technology is very important for our socio-economic development of the country. It is also important for our military purpose these days, for socio-economic development. Space-based observation can help in military, so surveillance, for military purpose. So, it has a crucial role in national security these days. And now, the Spacecom 2020, Spacecom policy, the Space Communication Policy 2020, it would like to increase the role of private sector in the space research and development and utilization. They want to increase, the government would like to increase the role of private sector in space technology. So, it is various aspects of, the whether it is in a nano satellite, micro satellite, or even large satellite. Okay. This is covers all aspects of nano satellite or micro satellite or even large satellites, all will be covered under this. So, this foreign rocket launch specially for send Indian satellite, yeah, I mean most of them have launched our satellite specifically. In some cases, they might have been sending it as an additional payload also, it depends. Okay. So, prototype means what? Prototype means a small version of a larger one. Okay. A prototype bus, suppose you make a small bus in your with a driver, everything which can run. Okay. So, if it's a small bus which you use it, if it is a ditto of the original big bus, then we call it as a prototype. What we want to achieve later on, a bigger version, if a small version is created, then it is called prototype. Anyway, so the space policy would like to cover all Spacecom 2020 would like to cover all communication or to increase the role of private sector, all aspects of nano satellite, micro satellite, large satellite, everything will be covered in this. And because there is a growing need in India, and industry should be a co-traveler along with Department of Space. That is the idea. Private industries should be a co-traveler along with DOS, Department of Space. So, it is for the commercial use. So, basically the private in the co-travel means for commercial use. Okay, commercial use of satellite, the orbitals, the slots in which we can launch the satellite, everything. Okay. So, but this private players will have to take some permission, some authorization from a from an agency. Okay, that I'll come to that. So, what are the objectives? So, mainly private player, we are opening the space technology and the satellite technology or the satellite commercial use of satellite to private players also. Objectives: number 1, to monitor and authorize the use of space assets for communication, to monitor and authorize use of space assets for communication. Number 2, protection of space assets and bring the space assets under the administrative control. Protection of space assets as well as bring space assets under administrative control. Okay, we are talking about objectives of the Spacecom policy. Number 3, increased participation of commercial Indian industry. I already said the main objective is increased increased participation of commercial industry or Indian industry in space based communication and better control, okay, and a regulatory environment or a facilitating environment for participation. That is the main objective. And one big policy, the objective I said. Now, some of the features. Of course, number 1, private players can participate for communication both within India and outside India. Private players can participate both within India and outside India. So, in communication field, private players can participate, number 1. And number 2, we can say any communication service within the territory of India only with an authorized, with any communication within India can be there only using an authorized space asset. Any communication within India can be only through an authorized communication asset or space asset. The meaning is, suppose you want to relay something to India, that satellite should be an authorized satellite, only through an authorized space asset. Then only Indian entities are eligible to obtain space asset authorization. That means this authorized asset should be, that authorization should be taken by an Indian company, only Indian entities. Can take authorization. A foreign entity cannot take authorization for relaying something in India. And also, Indian companies can establish telemetry, tracking, command, earth stations. Okay, Indian companies can set up right now. All these things are done only by the government setup. Now, Indian companies can set up tracking, telemetry, command, centers. See, that means basically we are saying that even a private player with authorization from government of India can even launch satellites, and they can have tracking facility, they can have telemetry facility, they can have command facility, but of course permission from the authority. Okay. So, it can help in the social empowerment and all, and also a new Indian National Space Promotion Authorization set up, and an independent authority will be created. Okay, an independent authority for authorization purpose. An independent authority for authorization purpose will be created, called IN-SPACE. Okay, an independent or authority for authorization purpose called IN-SPACE. Okay, INSPAC capital and E small. Okay, what is that? Indian National Space Promotion and Authorization Center. Indian National Space Promotion and Authorization Center, an independent body under DOS. Department of Space. So, they will give all necessary authorization and permission. So, we are creating a new independent authority under DOS to provide these permissions, authorization permission for all satellite companies, okay, or all satellite communication related activities, for all SATCOMs. Satellite communication facilities in the territory of India. Okay. So, IN-SPACE is an independent body under DOS for all authorization and promotion activity or permission activity, and also it has also decided to create another organization called New Space India Limited. a limited company for commercial activities of ISRO. New Space India Limited, a PSU, public sector unit, limited company for commercial activities of a new company. As per the policy, they decided to create a new Space India Limited, NSIL, New Space India Limited or NSIL, is established in 2019. Okay. Of course, this policy has said that we are creating it even before that, but the idea was this. So, why this new policy? First of all, the demand for the satellites have increased, almost 18 to 20 satellites per year is required for India now. Number one, demand for satellites increased. (18 to 20 satellites per year), and ISRO will find it difficult to meet, to spend that much money. Even resource mobilization is a problem. ISRO will find it difficult because the demand has increased manifold. Number two, now ISRO, we are spending, the scientists, a large chunk of the ISRO manpower, now a large chunk of ISRO manpower is used in commercial application, meaning manufacturing this rocket like that. They could have been, they can be, if private sector takes over, technology will be there with ISRO, but they can use the private sector to develop or manufacture. Manufacturing activity can be done by the private player. So, ISRO scientists can concentrate on research and development. Okay. ISRO scientists can concentrate on R&D, and also in a rapid digitization the country is going on. Okay. And number 3 point is rapid digitization of the country. So, we need more capacity development. So, we need massive capacity development, and we need support from the private sector, and private sector also will contribute to this. Now, everything is spent by the government. It will also create huge job opportunities. If more private players come into picture, more investment, more job opportunities, and this can also be an export. India can become a major exporter of the satellite technology to the rest of the world. Major export opportunity. major export opportunity for India. So, these are some of the benefits, and this is what exactly the new SATCOM satellite communication policy or space communication policy 2020, but the benefits will be long term. It can be part of the Atmanirbhar Bharat of our great Prime Minister concept, no doubt, but it is not going to give us any immediate benefit. That is the only problem. Long term benefit will be there. Now, private players will come, they will start investing. If the results may be there after 10 years, 20 years, maybe it will take time. So, this in space, once again, let me just remind you the authorization and processing in space is an independent nodal agency and is for promotion and authorization center. It is a promotion and authorization center. So, it will be a single window nodal agency to oversee the activities of the private companies. Single window nodal agency oversee the activities of private companies. Oversee the activities of the private companies. So, another interesting thing is the new Space India Limited, which is created, the commercial arm of ISRO, will also be under IN-SPACe, or rather even NSIL, the new Space India Limited, the commercial arm of ISRO, will also be under, or its activities also will be under IN-SPACe. Even NSIL will have to take permission from IN-SPACe, that is the point. Okay. So, that there will be a level playing field for ISRO as well as the private players, for a level playing field for ISRO and NSIL and private players. So, private players will get a level playing field, and the decisions of IN-SPACe will be final and binding, including NSIL. Decisions of IN-SPACe will be final and binding, even for NSIL and ISRO. Okay. And private, so private players may not be taking any permission from ISRO now. Private players will be taking permission from IN-SPACe. So, private players not required to take permission from ISRO. So, Gaurav is saying that, sir, it seems that a few companies now in the coming days will dominate the space field also, like Adani and Ambani. Exactly, no doubt regarding this. Now, we are allowing, not everybody will be able to come into this sector, and every likelihood is Reliance will come into picture. Why? Because they are already having their communication network, and they have what you call the geo network for them. So, they may be very keen to have their own satellites also in future. So, they may start dominating. So, if there are only one or two players coming and entering from the private sector, and they may monopolize in future, and it can be disastrous for the country. That is the other side of the story. We do not know. Right now, no private player has entered into the field, but if only one or two comes, and if there is no proper competition, like what is happening in the telecom sector, only Jio and Airtel, and if our Idea and Vodafone collapse in the coming days, it will be a duopoly, only two companies, and they will dictate terms, and we will be in great trouble. I will say this government is single-handedly responsible for the demise of, we had 8 to 10 private communication providers. One by one, we lost one by one because of the government policies. These companies went in big failure, they had to close down, and now we will be left with only two companies, Jio and Airtel, which will be very dangerous for our country in future. Anyway, so in space, what will be the exact structure and all, it is not very clear. There will be some, like a Telecom Regulatory Authority of India. Similarly, we have Space Regulatory Authority or in space. That is how it is being talked about. Okay. And the New Space India Limited, see, please remember just a couple of points about the NSIL, New Space India Limited. This is a commercial arm of ISRO. Earlier, we had a commercial arm called Antrix Corporation, Antrix. See, Antrix Corporation was a commercial arm of ISRO for quite some time. It is still there, but it was under the department itself. Now, NSIL is a public limited company. New Space India Limited is a limited company. It is a PSU, Public Sector Unit Company, and it will act as a professional company. Now, what has happened is, when Antrix enters into some commercial deal, and if there is a dispute and all, Government of India, Department of Space is involved. Now, Department of Space will not be involved. This company, like any other PSU, Public Sector Unit, like Steel Authority of India, or SAIL, or Aluminium Production, or any other company, any other public sector unit, this NSIL also will act as a public sector unit. Okay. So, this was announced, NSIL formation was announced in July 2019, immediately after Prime Minister Modi came back to power, and Finance Minister Nirmala Sitharaman, in the budget speech, she talked about creation of a new commercial arm or a public sector unit company called NSIL. So, it has already started functioning. So, the objective is to, this will act as the government agency for transfer of technology, creation of small satellites, this, that and all. So, in all these areas, the NSIL will act as the public sector company or a limited company for pure commercial purpose. That is what exactly we are talking. Then another thing I would like to talk right now, I already talked about the in nano satellite, micro satellite, what is that difference? I would like to talk about that. Okay. So, that satellite classification, satellite mass classification, how satellites are classified. Now, the next thing I would, so I have talked about the new in space NSIL, why the new satellite policy, satellite communication policy, space communication policy 2020 we have talked about, and the drawback we have already seen. A few companies will emerge, they may monopolize, there can be disaster in waiting. If, see, privatization or allowing private player itself is not a bad idea. Please remember that. We need private player, private investment also. But this should not lead to a scenario whereby only one or two will enter into this market and they will start monopolizing, and then they start extracting money from people, and if they become a monopoly or a duopoly and manipulating things, if the government is hand in glove with them, this will lead to crony capitalism. What exactly is going on in the name of Jio? Ambani started and he destroyed all other companies and he will become the monopoly, and it is going to be disastrous for the country. Right now, Jio is offering very cheap services, very low cost service, but how long they will continue like this? It's anybody's guess. Once he destroy all his competitors, then he will decide the cost or rather the pricing according to his choice, and it can be disastrous. Okay. So, coming to satellite mass classification. Ash is asking if the class timing is 4:30 to 7:30. I never said that. ये मेरा मर्जी. Okay. I may stop any time. तुम ये क्या बोलना चाहता है आशीष कि आप पढ़ाओ, खड़ा हो जाओ और पढ़ाओ, मेरी चॉइस है, मेरी मर्जी. ओके. मन करेगा तो मैं 8 बजे तक भी पढ़ा सकता हूँ, मैं अभी भी रुक सकता हूँ. तो मुझे मत समझाओ कि 8 बजे तक पढ़ाओ, 7:30 बजे तक पढ़ाओ. Okay. So anyway, so when we talk about the large satellites, if it is 1000 kilogram plus, medium 500 to 1000 kilogram, small, so rest is all small. So there is a mini satellite, (100 to 500 kilogram), micro satellite 10 to 100 kilogram, nano satellite 1 to 10 kilogram, so please remember this. Nano means 1 to 10 kilogram, then pico (100 gram to 1 kilogram), then femto 10 grams to 100 grams, then even 1 gram to 10 gram satellite also called atto. So nano satellite, we these days you hear a lot about nano satellite and micro satellite. So please understand, Baki in future it may be atto and all, but most importantly Please remember micro satellite and nano satellite. Nano is 1 to 10 kilogram, don't forget. Micro is 10 to 100 kilogram. And then we have also this, the CubeSat, etc. One second. Yeah. There is also a concept of CubeSat. So, nanosat, microsat, CubeSat. It's a type of nanosat. Okay. So, it is not like a cube, don't mistake. So, it is sometimes the shape okay, something like this, the CubeSat. So, or the vertical cubical column, that is something we can easily think. Okay. So, there is something called CubeSat, like there is something called in a dimension, there are many 1U CubeSat, 1 unit, 1U CubeSat means the size may be 10 centimeter into 10 centimeter into 11.35 centimeter. 1 unit. Then there is something called 2 unit, 2U CubeSat. It is 10 by 10, 10 centimeter into 10 centimeter into 22.7 centimeters, 2U. So, it depends on the size, that vertical size. Then you have 6U. That is 20 cm into 10 cm into 34.05, 6 unit, then 12 unit. Okay. So, that is 20 by 20 by 34.05. So, these are called nanosats, but like a cube, but not exactly the cube shape. Okay. So, it is not exactly cube. Cube means all 4 or 3 sides, all 6 sides should have been equal size. That is not exactly. Side length difference will be there. So, 1 unit cube is a 10 centimeter by 10 centimeter to 11.35 centimeter. If it is there, then we call it as 1 unit CubeSat. A CubeSat is a type of nanosat. Okay. CubeSat is a type of nanosat. And there is also the smallest exiting CubeSat is 0.25 unit. Okay, the smallest till now. .25 unit by China. Okay, and the largest can be up to 27, it seems. Largest CubeSat is 27 units. Anyway, so that is the difference between. So, a nanosat. So, India has launched a couple of many nanosats we are launching, especially the various universities. Okay, Anna University, SRM University, all of them are sending some of these nanosats. Okay, that is how these names, and some of them are CubeSat. Okay, that is the meaning of it. Okay, so please understand that. So, CubeSat, what is the thing? The nanosat. Nanosat means 1 to 10 kilogram. 10 to 100 kilogram is a microsat. Okay, so these are some of the different. Now, having understood these basic things, now the next discussion will be on our. I will be continuing with the satellites. Then I will move into launch vehicles. So I will be talking about the remote sensing satellites, the IRS type satellites, remote sensing, Indian remote sensing satellite. So that I will be taking up tomorrow in the next class. Ashish mein